Hello, we are starting on page 167, lesson 1. We're going to be going through lesson 1 and lesson 2, but we're actually going to do one part of a warm up and then a getting started prior to those lessons. So let's go and get started on the warm up here. The topic for this new module and topic is proportions and then learning about linear relationships. So we're kind of going a little bit away from geometry, now going toward proportionality and lines and things like that. Anyways, our learning goals represent proportional relationships with tables, lines, and equations. We'll be comparing graphs and then comparing different ways to represent linear relationships. I'm going to go through number 2 here. So it says determine each unknown. Okay, so we have these two fractions. We have t divided by 90 equal to 5 divided by 9. Now, this way, we can figure out this multiple ways. So you can look at like linear relationships like from here to here, like that. But something that you need to kind of have in your toolkit of like math processes is when we have fractions that are equal, there's a process of cross multiply. I'll abbreviate there. Okay, so in order to figure this out, we're going to multiply here and we're going to multiply here. And we're going to have an equation that we solve from there. So let's use this one first. 90 times 5. 90 times 5. Actually, we'll write this out. We'll do 9 times t and 90 times 5. If you multiply this, 9 times t is just 9t. And 90 times 5, think about 9 times 5. That's 45 and then add a 0, so 450. In order to solve for t, 9 is multiplying. I'll put a dot there. So you'll have to divide both sides by 9. 9 divided by 9 is 1 t or just t. And 450 divided by 9. You could just think about what is 45 divided by 9. That is 5. We actually just did that. So t is equal to 50. All right, another way you could have done this, so you can cross multiply. You could just see in the relationship here, right, you'd have to divide by 10. So you just think about what do you divide by 10 to get 5. Oh, sorry. Oops. Let's put 10 there. Or you could go the opposite way. 5 times 10 is 50. All right, let's go ahead and get to the next page, page 168. This is getting started. And we're looking at ratios. So ratios, you typically learn in Math 6, review Math 7, and then we continue in Math 8 to get to linear relationships. Okay, so it says a ratio of females to males. Here we're going to highlight some things. It says government agencies and civil rights groups monitor enrollment data at universities to ensure that they fully represent all groups. One study focused on the enrollment of females at a particular university. The study found that 3 out of every 5 students were female. So we're going to represent some ratios here. We're not going to do any math. We're not going to perform any computations, but we'll write some different representations of ratios. So it says use the findings of the study to write each ratio. Number 1, what is the number of enrolled female students to the total number of students? We just said it was 3 out of every 5 students. So we can write this as a fraction. This would be represented as 3/5, right? 3 females for every 5 students. We can also write this as a ratio with a colon, right? So 3 colon, so this translates to 3 to 5. Or you could actually write out the words, or write out the word 2. This is also 3 to 5. Okay, number 2. What is the number of enrolled male students to total number of students? So if every 3 females, if out of every 5 students, 3 of them are female, well, in this case, we're going to have to make some assumptions. We're just going to assume for 2 genders there that this will be 2/5. All right, so let's also represent it in the other ways. This will be 2 to 5 with a colon, and 2 to, oh, whoops, I actually write out the word. 2 to 5. All right, and then these other two are slightly different. I'm going to go through number 3, and I'm going to ask that you pause and try to figure out number 4. But number 3, the number of enrolled female students to the number of enrolled male students. So we're not looking at total anymore. So we talked about how there was 3 females out of every 5. So we're looking at, for the denominator here, is to represent male students. So this will be 3 over 2. So as a ratio, 3 to 2, and using words, 3 to 2. Okay, I'm going to ask that you pause here, and you're figuring out the number of enrolled male students to the number of enrolled female students. It's going to look very close to what you have here. So give that a shot. So this is you do. Okay. Let's go to the first activity, though, where we're looking at equations. So activity 1. Representing proportional relationships. So we have these equations and represented using fractions or just numbers in place of variables. So it says choose the correct equation to match each description, and then we're going to compare some equations on the next page. So A, the number of female students enrolled. So number of female students enrolled, that's represented by Y, and we'll put in red to the total number of students, and that's represented by X. Okay, so which one do we think represents that here? So we talked about how this is 3 in total number of students out of every 5. So what equation can we use? We're going to be using, that is this equation here. That is Y is equal to 3/5 X. Right, so total number of students Y, female students is Y, and X is total number of students. All right, let's go to the next one. The number of male students Y, and then in red, and this is also total number of students represented by X. So this we talked about earlier. This is 2 out of every 5. So we're going to look at something that has 2/5. And that is this one right here. So let's represent that. Y is equal to 2/5 X. Okay. Let's do one more. The number of female students Y, and then red X as male students enrolled. So this was like number 3 on getting started. 3 out of every 5 students. So that leaves 2 male students. So we're gonna have a fraction that is 3 over 2. Where's 3? 3 halves. Y is equal to 3 halves X. Okay. So for this, I'll leave you to find. So this is a you do here. Pause this. Try to figure out this one. Let's go to E though. Describe the similarities and differences of each of the correct equations. So each equation is in a specific form. So we'll say each is of the form Y equal to, there's some type of value that goes in before X. We're going to leave a variable there. We'll say K. So Y equal to KX. Okay. Now this is where K is representing a ratio, right? K is the ratio. In this case, it was always Y to X. So we'll write it like that, Y to X here. Okay, and that value of K, that was different in each equation, where we always had this starting with Y, and it always ended with X. All right. Now we talked about how we are going to represent this in other ways. We represented an equation in a ratio. We're going to go to the next page, page 174, activity 1. Okay. It says, describe the similarities and differences of the two graphs. So let's look at our X and our Y axis. So the X axis here is total number of students, and the Y axis is number of enrolled male students or female students. We have it color coded there, so that's nice to see. So what can we say about these graphs, right? What's similar between, when I say graph, I don't mean the entire graph, I mean this line or this line. What is on either green or looks like an orange. So that's what we refer to in graph. We'll say both graphs, they go through the origin, so both graphs, we'll say go through 0, 0, so that's a key point to notice. Okay. Both are, now when we say lines, it's implied that they're straight lines, so both are, we have to specify straight lines. Okay. And then, right, one is obviously steeper than the other one or more vertical compared to horizontal. So here we know that what's in kind of this green color here, that is representing female students, that's a little bit steeper. So we're going to say green / female line is steeper. Okay, right, so steepness is an important idea for this topic. Anyways, so let's get to some key vocabulary terms we're going to be highlighting here. It says the relationships in the lesson are what we call proportional. So proportional is a key vocabulary term. It says a proportional relationship is one which the ratio of the inputs to the ratio of the outputs is constant. So constant meaning that it'll never change, it's not variable. So for example, the ratio of females to males at a university was 3 to 2. It always stayed at 3 to 2. Like an example could be, let's say 6 to 4. Right, well 6 to 4, that simplifies. If you divide both of them by 2, it's 3 to 2. So that is a proportional relationship. Okay, you always write the equation for a proportional relationship of the form y equal to k times x. And that k has a specific name, where x represents the input value or something that's independent. Sorry, let's put x here. And then y represents the output value, something that's dependent. An example of that is like a vending machine. Like what you, right, your money is independent. What's dependent from that is the item that you get from that vending machine. That depends on what you put in. And k represents some constant that is not equal to 0. And the k constant, the constant k is the constant of proportionality. So let's highlight that. Let's also highlight proportional relationship. So constant of proportionality. Okay, and that is k. So number 3, identify the constant proportionality for each relationship in question 1 on the previous page. So we're just going to do it for maybe 2 or 3 of them. So the first one that we got was y equal to 3/5 x. So the constant proportionality, k, that's the 3/5. All right. The second one, we had y equal to, this is on the previous page again, y equal to 2/5 x. Right, so the constant proportionality, k is equal to 2/5. Right, so nothing too complex there. We'll leave it at that, just going through the first 2 problems. Okay, and let's go through problem 4. Identify the constant proportionality or rate of change for each graph in question 2. So in the graph above. Then it says, then explain how to determine k from the graph. Okay, so there's a couple ways that we can determine this. Now we have right, these values here. These are our coefficients of x. So we have 3/5 and we have 2/5. So let's write that out. Okay, so we're going to say for females that are enrolled at the university, we'll say females enrolled, comma, k was equal to 3/5. All right, for males, all right, so we can say that there's more female students than male students that attend. We're going to say k is equal to 2/5. Okay. All right. So how do we determine this? So we can determine this from, right, the equation, but how can we determine this from the graph? Where do I see 3/5 at? right? If we look at 3/5, I'm gonna go right here, and we'll find on the x-axis 5, right here, where they intersect, right here and right here. That's a point that's on this graph. And then for 2/5, I'll put this in a different color, put this in red. 2/5 is right here, and well, 5 is in that same place. Let's see where they intersect. Right, also on it, so it's a point on the graph here, right, for each one. So we're gonna say, right, how can we find the constant proportionality, or it's also called rate of change from the graph? Well, we'll talk about for females. So for when k is equal to 3/5, we're gonna find 3 on the y-axis and 5 on the x-axis. Okay, we're gonna leave it at that. We'll go over activity 2, which is 171 together. So for this, if you do finish, I'm gonna recommend that you work on Mathia, and then we'll complete this together. But we're just completing the warm-up, getting started in activity 1. We'll call it there.